So welcome everyone to another one of the Siemens webinars on the SINUMERIK control. We're going to get a chance to play around with some advanced technology in the forms of multi-channel machining. This will be a G-code centric webinar, so it should give you a good understanding, especially if you're maybe working with this type of technology and you're going to drive them from an external CAM system. We're going to be obviously doing some longhand programming, but the functions, the formatting, it's really going to be the same. So again, thanks everybody for joining us today. I am your host, Chris Pollock, and today you just get me. So certainly as of late, we've been having a lot of guest presenters come in. It's been a lot of fun, but today it's just me. So you're gonna have to put up with me the whole time here. But what I have the pleasure of doing for Siemens is I create a lot of our online content. I also get a chance to manage a great team of guys that help support me in the market space and support Siemens in the market space. But from a reference, you can always reach out to me for help and assistance. So there's my contact information. So please feel free to reach out whenever you need a little hand. In our events, I always like to kind of prime for what's coming up next. And as I just said before, we've been doing a lot of collaboratory events, which has been a lot of fun. So I am inviting in one of my NX colleagues, so of a sister division within the Siemens side, our CAM system. And we're going to do a collaborative segment on really highlighting some of the key features within NX and how well they marry to the SINUMERIK control. So we're going to get into some advanced machining techniques, and we're going to get a chance to see them in action on my machine here in the lab. So take a look for that. That's coming out in April. Now, before we get into the core topic, certainly for any of you guys that are new to the event, I'd always like to get a chance to show you an area where you can start to gain some additional resources here. So all of our webinars, whether they're promoting the next coming one or just getting to a catalog listing, we have links to all our past webinars that can all be found right here on our CNC4U website. So by all means, if you haven't been on the Siemens CNC4U website, use the web address you see right at the top of the page. Then from there, there's links to the webinars. We do offer training classes. Now, it has been a bit challenging, obviously, with the current situation with COVID to do in-person training. So it gave us a great opportunity to switch a lot of our content to online instructor-led training. So if it's something you're interested, I would check out under the training tab, our online training. We have a bunch of classes listed there. And it's not just basic too. I have a advanced variable programming class coming up. I think it's in April. But if you guys can, or if you're interested, certainly check it out. Classes are all free of charge, but space is limited. So, once we start to do in-person training and we want to interact with our attendees, we do have to limit the course sizes. But these are multi-day training events. So there's a lot of material you'll get from them. Additionally, we do a lot of content on YouTube on our Mr. CNC channel. So if you haven't taken a look at the Mr. CNC channel before, just browse over to YouTube. You can just do a quick search for Mr. CNC or look for some SINUMERIK content. Typically, you'll stumble across our channel. So there we have, we do post the webinars. So this recording will get posted up there, but we do a lot of content just for YouTube. We also have a YouTube live segment. So check it out. Certainly there's even more information you'd find there. So a couple good sources for you guys to look at. And we do also have a virtual product expert program going on. We've had it for, well, we really rolled it up, and we've had it for quite a while, but we really kind of pumped it up, so to speak, right? We started utilizing it even more during these COVID challenges. So what this virtual product expert program is just an opportunity to be able to book time with a product specialist within Siemens to really talk about any and all things SINUMERIK. We certainly will focus primarily on operation and programming topics, but if you guys need help from a service or support side, we can also bring in other colleagues. So my colleague Daniel Vitullo manages that. His contact information is on the slide here. So if you'd like to take a look at that, and you can also get to this program right from the CNC View page. There's a link on it there too. So you can put a request from our CNC View website, or you can email Danny directly if you're interested in maybe booking some time to work with one of our product specialists. Oh, and this would be where you would see it on CNC View. So I guess I was a little bit ahead of myself. Okay, so that's just a primer on some back-end stuff, but I do want to get right into the material because we have a lot to talk about today. As far as questions, but feel free to plug them into the Q&A panel or in the chat. Sometimes it's a little easier if we put them into the Q&A. We will do a Q&A session at the end of this, so just reserve them there. If I see something out of the corner of my eye that I can throw in immediately, I'll try to, but if not, we will try to get to all the questions at the end. So today's topic typically will focus primarily on 840D controls or on our latest variants of control we're just releasing now, which is the SINUMERIK 1. But even in the 828 world, we do have the ability of supporting two machining channels. So this isn't just restricted to 840. So a lot of this content could actually work even on an 828. But typically when you get into this multi-channel world that we're going to be talking about, it's going to be primarily reserved for the 840D control or our latest control, which is the SINUMERIK 1 control. Now, I do always like to reference some supporting material that you guys can go back and get more information on the topic. And what you see here, this is a little snapshot of the Siemens CEOS website. So Siemens Industry Online Support Portal. So that website, you can get to it from the web link that you see there, allows us to get access to all sorts of stuff. So manuals for sure, but you can also get white papers, there's all sorts of discussion boards. So I would say it's a great resource when you're looking for anything within the SINUMERIK realm. But in this case, if you can get yourself, download the operating manual for turning, you can search for the number there, which is the document number. This manual has a great section on specifically multi-channel machining. And if you look on the little screenshot of the title page there, you'll see in chapter 11, we start to delve into multi-channel machining. So a lot about what I talk about today will be referenced within that manual. Now, today's segment is really the last of a series of webinars I've been doing on the CNC technology, the SINUMERIK turning, specifically CNC turning technology within SINUMERIK. So we started, and this has probably been going on, boy, quite a few years, right? It takes some time to fit in all the different topics as we work through. So what I'd like to just show you is there are a series of webinars we've previously hosted. There's going to be a lot of material that we're going to kind of jump over that we've hosted in previous webinars. I'll probably reference it again. But if you'd like to kind of check out the whole series and you haven't seen some of these, and maybe you have a multi-channel machine but it has a B-axis. I'm not going to get into B-axis today, but you can reference the B-axis webinar, and we talk about that quite a bit. You can kind of plug the pieces together. Part transfer. We'll do a simple transfer now, but I did a whole webinar on working with sub-spindle lathes, and we did a lot for the whole process of part transfers in G-code. Y-axis, working with C-axis and Y-axis. So there's the series of webinars. Probably the easiest way to get to them is if you go to the Mr. CNC channel. We do have playlists now, and we're starting to try to categorize a lot of our material under the playlists. So go to the SINUMERIK Turning playlist, and it will have links to these webinars as well as a few more, but certainly all these webinars can be found right in that playlist. So check that out, and by all means, utilize some of this material for sure. So what do we mean by a multi-channel machine, or a multitasking machine is also quite commonly referred to? Well, usually we kind of think of these specific to turning technology, right? So it's a lathe with some kind of milling attachments, maybe it's a Swiss style lathe. It doesn't actually stop there. This multitasking technology can certainly transcend out of the traditional turning, milling type of machine configuration. We get into milling machines that have secondary channel segments. We certainly get into machines that you integrate robots to the machine, but the robot is actually being run by the second channel. So you can do collaborative functions and processes between a robot and a machine tool. I've seen scenarios where you could be doing loading and unloading of the table while the table's in motion, right? Because now they can be fully synchronized. So we are going to look at the most common application, which would be a turn mill type of configuration, but don't limit yourself to just that concept. So the structure and the functions I'm showing you are really going to be very similar, even if you found yourself on a machine that has a robot and it's using this Run My Robot application for us, and you're running it and driving it as that second channel. So we are not limited to that standard technology, but in our case, this is kind of what we're looking at. So here's a quick little video to show what we're talking about as a multitask. I will apologize, it's usually a little bit jerky through the WebEx tool, but I think it still kind of gets the overall concept, presents it quite well. And what we're talking about here is the ability of having two separate programs running simultaneous. They're running actually asynchronously, so they're not synchronized initially, but then through a series of adding wait code statements or other types of commands, we could then also synchronize. So we're going to start looking at a little simpler style technology. We won't have a full B-axis like you see here. We're going to have an upper turret that happens to have a Y-axis, as well as a lower turret that happens to have a Y-axis. We're going to do some basic timing, but it does go beyond what we're even going to see. So we won't get into it, but we have full pinch turning capabilities. So if we want to synchronize fully the upper and lower to do like lead follow type of applications, that would be kind of coming next in supplement to this. But what we will do is we will walk through. We're going to use the upper turret to do some work on one of our main spindles. We'll use the lower to jump over to maybe the counter spindle, and we'll flop back and forth to give you an overall view of the structure of this type of technology. And there she's finishing up a little bit on the main. Obviously, we would do a part transfer. Okay. So what are some of the pros to this technology? What are some of the cons? Certainly, you can start to reduce cycle time. There's a lot less part handling. We can potentially complete a part in one setup as opposed to moving it through different machine applications. Works well, and it's for lights out based machining. And it's going to increase your productivity and also your precision, because you're really handling the part a lot less, right? We're leaving it completely within that machining environment, so there's less interaction that we have to worry about having our operators come in. However, machines can be quite costly in this this machine tool environment. Programming tends to be a little bit more complex, for sure. You have a lot more going on. And setup operation adds a whole new level of complexity. So what we're going to show you is, at least we've been trying to address the complexity side in our control and try to simplify the process as much as we can. So step one would be kind of getting your head around the kinematic makeup of these types of machines. So here you'll see this would be a scenario where we kind of have an upper, lower. This machine happens to have a B-axis. Now, one of the tricks to kind of working within this technology to allow everything to talk to each other is you want to have a defined datum reference point, and everything will work from that scenario. So traditionally, that tends to be the face of the main or primary spindle, or your fixed spindle. Now, that doesn't have to be. You're going to get to different machines and they may change it around, but it is going to add a little more complexity to it. So if you can and you're on it, and let's say you're an OEM and you're commissioning a machine, you want to try to work from that common datum, in this case the spindle face, and let everything build from that. So when you get into these machines, you got to kind of start to break down and look at not only what are your axes available, but you want to start to kind of make yourself a little cheat sheet about which channel those same axes are assigned to. Certainly it can be a little confusing when you switch from maybe different machine types or different manufacturers. Everybody kind of sets them up a little differently. So what I always do is I start kind of looking at the machine, making myself a nice quick little cheat sheet. All right, channel 1, which are my axes? How are they assigned? What's my axis designations? That changes a lot too. So not everybody's going to call things X, Y, and Z. Or you could have multiple axes. One could be called X1, then X2 could be the lower turret. That's very common as well. So just expect to see some changes, especially when you look at from an OEM to OEM perspective. There's, everybody kind of puts their own spin or flavor on this type of configuration. So on our machine, we're going to be working from a archive that was built from a DMG Moray CTX machine. So this was a Beta 4A. So in this scenario, we have 2 spindles. We have a main spindle and a counter spindle. And then we're going to have an upper turret that has a X, Y, and Z axis, and a lower turret with X, Y, Z. And what DMG likes to do is they keep a consistent terminology from machine type to machine type, and they won't defer. So what they've always done is they'll establish the spindle or the C positioning of the upper turret is always designated S1. So if I'm going to turn on my live tool on a DMG, I'm going to know that's always my S1. And then when I come straight down to my lower turret, they're going to designate the lower turret to be S2. And then from there, they go to the counter spindle as S3 and the main spindle as S4. What's kind of nice about this is no matter what type of machine I come up to, I always know my main spindle is S4. So if it's only a main spindle and a turret, and maybe I had a tailstock on the machine, I'm actually using the turret being S1 if it has live tooling, and the main spindle being S4. And then S3 just wouldn't exist in that machine. So as they add the additional components, they'll just keep complying with that methodology of layout. I've seen other builders change it based on what the configuration is. So again, doesn't matter what the structure is, you just got to make sure before you start doing any programming, you understand which axis is which is assigned to which channel. So there's a scenario on the right side where I've kind of started to map everything out. And I'll always do that and kind of keep that cheat sheet next to me when I'm going to start writing programs for any of these multi-channel machines. Now, when we look at jog, there are going to be a few new functions or ways to start to move the machine around in a jog environment. You're going to see both channels potentially at the same time, and then I can start to toggle between them. So you will see the axes that are designated to a given channel. And depending on how they set it up, you might also see the other axes in the other channel as a grade scenario. So we can kind of flip back and forth and see these two setups at the same time, or we can hide one channel if I'm only working on one of the 2 channels. So then I flip to the second channel, and there you can kind of see what I was talking about. You see how the Z3 and the C3 axes are grayed out? They show you a display, but they're not as dark as an appearance as the other axes. That's just an indication to you that those axes actually exist in the other channel. Now I can view them from inside this channel, and obviously I would certainly want to. The Z3 in this case is the counter spindle, right? So in that scenario, that the position of that counter spindle is very important for my channel 2 if I'm going to send it to go over and work on it. But I also get an idea immediately looking at this different color designation, which are the axes in which channel. And then you get a new function under the settings mode, which now allows me to basically display or suppress the channels available in this machine. So what you see right now is what your jog screen would start to look like. So as I come in, I can view both channels at the same time, or I can hide one channel and flip the other one to be on or off. So if we transition over to Sinutrain, Sinutrain is our PC-based control emulator that we use in a lot of these segments. Here we can see this is what that machine would look like. I'm in the jog area. I see that I'm in jog mode. I can toggle between my actual values and my work coordinate values. Right now I'm displaying my machine coordinates, right? And you notice that if a display change should affect both channels. It'll affect them immediately. Now, if I scroll down, I can see these are all the channels in black that are designated to this, or axes that are designated to this channel. And then I see in gray what are suppressed. So in this case, the Z2, which if I look at my actual machine values, that's where my Z2 field comes in. That's the designation of the axis. Now, when I program it, I'm still going to address it just as Z. And then if I want to now hide segments of the channels, this is where you're going to go and navigate over to the settings screen. Under settings, once you have a multi-channel machine, you get this new button under general. And we have the ability of now toggling between one or two channels. And then if I want to select which channel I'm going to then be driving, I'm going to use this group channels button. So right here to the left of the little green keypad, you're going to see group channel. So that would allow me to toggle between two channels. So if I bring up both channels, back, now as I flip back and forth, see how I can change the state between the two channels. So if I have both channels up at a given time, and I say, well, I need to change my tool, right? I want to change the tool maybe in channel 1. Well, the TSM button that we've been certainly using for quite some time in this control and different technologies, when I hit it, this is going to be specific to whatever channel was active at that moment in time. So if I want to, just like I would normally do on a simple lathe, maybe load up this peripheral drill and cycle start, it loads the drill, but it loaded it specific to channel 2 because that is the channel, see this yellow highlight, that is active at this given point. I want to work on the other, I'll flip it back. Now, when it comes to jogging, moving them around, that's where the OEMs really kind of just make some determinations on how they want to set it up. I've seen some OEMs will drive the jog panel in their hand wheel from this group channels button. I've seen other ones, especially from jog, will maybe give you selectors for all of the axes, so you don't have to worry about toggling back and forth from a jog perspective. So in that case, when you start to jog the machine, when you start to hand wheel it, I would say you definitely want to defer to the OEM's manual to see how they decided to set up kind of mapping the jog and the hand wheel between the two channels. But fundamentally, this is how it starts to work. You got your channels, you can suppress them if you want, again, under settings, and the multi-channel, here we can turn things on or off, make them visible, make it not. So that's all starting to do from this environment or this area. Now, additionally, not only do we get that in jog, and here just up there's our next window and channel moving around. I was clicking based on my mouse. If you don't have a touchscreen, you can use your next window button to move the cursor around. But in addition to our jog area, you also have a couple key functions inside of MDI. So in MDI, we've added this new mode we call run-in. And run-in allows me to also select what channel I want a specific command to occur in. This can be not only handy in MDI, but the same functionality exists in the auto mode. So as we transition over to MDI in the control, if I go to my program control button, I now see a new button called run-in. And run-in allows me to now basically tell the system when I'm going to issue a command, do I want both channels to execute upon cycle start, or do I only want one channel? And maybe I don't want one of my spindles to actually take the command because I'm only doing pieces of it. See, by default, cycle start is going to execute both channels at the same time. You don't have two unique cycle starts and bouncing between them. You hit cycle start, whatever's in these two channels will execute unless I come into run-in and I suppress one of the two channels. Now what it's doing is kind of interesting. If you guys are familiar with our program test mode, PRT mode, if you look right up here in the corner for channel 2 or over here for channel 1, you'll notice it puts in a PRT command. So a PRT mode is that's like axis lock. In a lot of controls, we're used to that terminology. So now it looks like the axis is running, looks like it's doing something, but no motion will occur. The servos physically won't be running. So that's your PRT function. That's how we suppress the channel from doing something when we want to execute or issue a command. So in this case, if I cycle start right now, the machine would move both to that location. Had I just done the one, it would have looked like the other channel moved, but the one that was in PRT physically would not have moved. Okay, so I just wanted to kind of give you an overview. We have talked about this this topic in a shop turn variant webinar as well in even more detail, but I do want to get us into the programming area. So when it comes time to start setting up my machine, laying it out for a job, in the shop turn set area or conversational programming, if you've seen that webinar, we use this spindle chuck data area to do a lot. It calculates our handoff, our pick points. When you get into the G code, this doesn't have as much control over the program. You know, I always think G code to conversational is like, you know, driving a standard car as opposed to an automatic. But what this does do is it gives me the ability of laying out my chucks, my jaw projection, specific for simulation. So I'm still a big proponent for coming in and setting up this area when we go to set up a job. So where I get to this chuck data, it's under my parameters button. So when you go to your parameters, also we would think of parameters as our tool table or our offset table. You can go to the setting data option, and then you'll see a spindle chuck data area. And this is where we'll set up our job as far as our work holding is concerned. So navigate to offset, select the setting data area, then you'll see a spindle chuck data field. This is the same way I would do it in a single channel machine. So here, these values then are going to signify my chuck body size and my jaw projection for my main spindle and my counter spindle. Now you see the datum location is working from the back. So remember that first one of those early slides I showed you where I was saying we want to reference everything from a fixed datum, specifically, generally speaking, on the face of the spindle. So that's where that datum comes from. And this should certainly allow us to then change work holding pretty quickly without having to do any really changes of the machine parameters. So keep in mind when we're doing this type of technology and we are in G code, this is really just setting up our graphics. It's not going to have any bearing on the actual motion of the machine. Okay, so my next step, once I start to lay all this stuff out, I do also want to think about, you know, where am I going to send the machine? Where am I going to send my upper turret or my lower turret for a safe retract position? Kind of how does this all fit? Where do I want to send my counter spindle to, I like to call it my park position between machining. So all of this stuff I want to kind of pre-set up before I start running any programs. On simpler single channel machines, it's a lot easier just to kind of jump right into it and drive it as you go. But I find the more we do in the front end, laying out our job, the easier it makes certainly programming this type of technology. You got a lot of moving parts here, so you want to try to simplify it wherever you can. Now it's important when we start to position our safe locations to think about the position data. Is this a diametric value? Is this a radial value, right? Because depending on if I have my diameter mode on or off, it's going to have a dependency on this position. So kind of think that all through. You may want to just move the machine around physically, find that safe location. You know, once I've retracted my counter spindle to the park position where I would probably send it to do any machining that I was going to do on it while I was maybe machining the other one. So I have to think of, you know, nesting and clearance of the turret bodies. So once you kind of set up this layout, then I have a much better idea of kind of where I'm going to be going and what's going to be happening as I write the program. Now, we are going to require using two work coordinates to kind of flip back and forth between our main spindle and our counter spindle, and then allowing our turrets to adjust appropriately based on which one they're going to work from. So in my case, I'm going to set up based on the true datum of the machine being the spindle face. If I bring into account, just like we saw on this last slide, I know I have some chuck body here, 3.5. I have some jaw projection. I have a distance that I want my part to stick out. right? If I start to add up all those values, I'm going to have some kind of an offset, positive offset, in this case 8.450. So that is what we are going to plug into the z-axis field. And I'll show you ways that it can actually automatically write it for you. And this would apply for both the primary Z, which would be my upper turret, and also my secondary, my Z2, which would be my lower turret, because I want the ability of either turret being able to run on this primary main spindle. Now, just like the main spindle, the counter spindle has to have a work offset as well. So I like to use just the next occurrence of work offset. So if I'm using 54 for my main, I'll use 55 for my counter. So in this case, I now need certainly a larger offset for the Z and the Z2, but I'm also going to want to use our mirroring functionality, and I'm going to want to mirror both the Z and the Z2 axis. So what is mirroring going to do for me? Well, at this point, if we think about it, when I'm machining on my main spindle, all negative moves are into my part, all positive moves are away, right? Pretty traditional. You get a standard VMC, simple lathes. We've kind of drilled that into our head for years. If it's negative, as long as the face of the part is 0, if it's negative, I'm machining. If it's positive, I'm in a safe spot. Well, when you get to these machines where I have a secondary spindle and that's on the other side of the travel, everything flips backwards, right? So now all of a sudden I got to think, boy, positives into the part, negatives are back. If I have tool paths that are common between them, I can't use them, I got to rework them. Well, by mirroring the axes, it allows me to do just that. It flips the z-axis 180 degrees. So now all negatives are always into the part. And I kind of visualize building everything as if it's sitting in the main spindle, basically. So that's what that's going to do. Now these fields, these can be triggered by the part program, or you can set them manual, but I would say you want to certainly do both, or choose one or the other, but you want to make sure you're using this mirroring function. So I'm starting to build up this setup sheet. So how did I come up with some of these numbers? So I have a little kind of Excel workbook, so to speak, that I like to work from. This is something I've shown you guys in some previous webinars. So this will allow me to really calculate for my pick and place, but it's also going to kind of give me a good idea of what my work offsets are, so I can plug them in. So if you'd like to get access to this document, I'd be happy to share it. Basically, the way it's going to work is you come in. So if I, changed my jaw projection on this job, maybe it's now only 1.5 inches. Maybe I don't want my part stick out to be quite 3 inches. Maybe I don't need it. Maybe it'll be 2. So what you'll see as I move through, it updates the areas in red. So really the green fields are intended for you to fill out. There's some options over here on the right as well. And then from there, it's going to calculate a bunch of things for us. And what it does is it calculates the work offset for my main spindle. It's going to calculate the work offset for my sub-spindle. It'll calculate the pick and place for my transfer position. So as long as I give it my transfer point, how much do I want to throw onto the part here under transfer position? It'll calculate where I'm going to send the counter spindle as I move that Z3 axis into place. So this is what I use to really kind of lay out any job I'm going to work on. I figure out how much my projections I want to be based on the cutting conditions I want. I'll let this kind of spit out some of these offset values. And then, like I said before, I'm going to go back and I'm going to give myself a nice little kinematic cheat sheet that I have in front of me. And then what I also want to do is start to lay out the job, right? So I want to think about, and I might take a scratch piece of paper, write channel 1 on the left, channel 2 on the right, and start to methodize my part. So I'll look at the part print, say, okay, what do I have to do? What do I want to do first? Am I going to face? Am I going to turn? Am I going to drill? And then which of my turrets do I want to do that? Because the channel is specific to the turret, not the spindle. I can take either turret and cut on either spindle. So always think of that. Channel 1, that's turret 1, right? That's, in this case, my upper turret. Channel 2, that's turret number 2. That's my lower turret. So which ops do I want to do? So once I have that, once I have my basic layout, my kinematic cheat sheet, because when I start to actually program the axes, I got to remember, hey, what is the counter spindle motion? Oh, that's Z3. So if I have that laid out for me, then I don't have to stop and go back and try to figure that out. And then what are my ops? Okay, so this is our job. This is what we're going to write a program for right now. We are going to come in. We are going to take our upper turret, our channel 1, and we're going to face off the part. Now at the same time, if we can visualize it, there's also a part sitting in the counter spindle, because at some point we'll handle a transfer, right? So I can take that lower turret, come down and face off. So now we'll bring everything to our final length. Once I've done that, I'm probably going to want to machine. Now this is going to be coming from 4-inch bar stock. So I'm going to machine this OD area first. And at the same time, assuming there's nothing in my way and I don't have any nesting issues, I can also machine the backside. So I'm going to allow the upper turret to handle the main spindle and handle this front operation. And then I'm going to let the lower turret do the counter spindle and machine this tapered application, right? So these are all going to be in what I'm considering operation 1. Then from there, I'm going to grab a drill. We're going to drill this hole. So now in that case, I decided, you know what, for whatever reason, maybe it's tooling, maybe it's a horsepower, who knows, I made the choice that I'm going to drill this 1-inch hole with an insert drill that's sitting in my lower turret. And then I do want to make a decision as to what's happening during this operation. Do I want to allow the upper turret to go work on the counter spindle at that point, or do I want it to stay in a park position? I'm going to show you how to stage the other one, so we can just kind of leave it hanging out there. Certainly, they could both be doing things simultaneously, but sometimes you'll find with nesting, with all sorts of other reasoning, I may not want both turrets running at the same time all of the time. You don't have to do that. You can have it kind of waiting, and that's where we get into these little wait state commands to trigger it. So once we've gone through, we've drilled it. On the opposing side, I have some 1/4-inch holes wrapped around, so a little bolt hole pattern here going on. So that one I'm going to do with my upper turret to show you how we can send either turret to either work holding. And then when we wrap up, we're going to take this part, transfer it from the main to the counter. So then this way, a simple cycle start, and we could go into full production. So then I just need a bar feeder, probably some kind of simple unloading mechanism, and we could just methodize this part as a lights out machining application. So when I start writing programs in the multi-sync, multi-channel area, if you have the option, you're going to get a new button called multi-sync. So we're going to see that, and we're going to see that available for us only when I'm in the workpiece directory. And the reason being is this multi-sync is going to create what's called a job file with a .job extension, and I can't have job files in the part programs or subprograms area. So we're going to go into workpieces. We're going to create a folder structure. I like to make a folder for each of the jobs I'm doing, instead of like traditionally on simpler technology, you might dump all your programs in the part program area. Here, the kind of the cleaner you can make your structure, the simpler it's going to be to maintain these jobs. Once we've selected multi-sync, then we can come in, we can define what our 2-channel program names are going to be. It's going to auto assign a name for us. We can select what the type of programming method is going to be for each of the 2-channel programs. So you're not locked into everything being G-code. I could literally have my channel 1 for my upper turret be a G-code program, and my lower turret was a conversational, a shop turn program. That's absolutely possible. And then when you say okay, you are going to see this multi-channel data screen. So this you always see, whether you're programming in G-code or in conversational. We're always going to see that. From getting to this point, we say accept, then it's going to create this cycle 209. So this is what your actual job file looks like, and then it's going to drop us into the editor. Now, job files, if you have them and you want your CAM system to output a job file, you can absolutely do that. And this would be the way it would look like out of the CAD/CAM system. You would have a select command, and then it would be called whatever the name happens to be. This one was, when I took the screenshot, it was called Demo 1. So this would be the name of the channel program for channel 1. You would have select, again, the name of the file for the program for channel 2. And then this cycle 209 string, that's what handles what you're seeing here, take it out of our way, for setting up our graphics, as well as whether or not I wanted to write offsets, what work coordinates I'm using, but more from the graphics standpoint. So don't think that we have to do all this right at the machine. It probably becomes a little easier to do the job file at the machine and then just bring the tool pass over from the CAM system. That's another alternative we can look at here shortly. But once we get in, we've established this, then it's just a matter of really setting up our nesting. And all of this is really driven from setting up this layout. You know, what was my projection? What was the amount of material I'm taking for a facing cut? How much is it going to project out? So all of these numbers that we're going to have in there were all pulled from that table, and then I just filled them into this sheet. We're going to say okay, and then we're going to be into the editor segment. So a bunch of steps there. Why don't we start getting into creating the program? So when I want to build a program, I'm going to go over to Program Manager. As I mentioned, I'm going to want to create a new folder. So let's call this part, oops, helps if I say new. I want to do new. I want to create it as a directory. And I'm just going to call this part 1. Oops, part 1. Okay, so that is going to be my folder name. So now once I've created the folder, the system has some intelligence as well. You might want to write a program. So it immediately gives me the option of starting a program. Had I hit cancel or not let it to, I could then be in the part 1 folder and say new right now. Both are going to do the same thing. But instead of starting a traditional G-code or shop turn program like we usually would, this is where we get this program sync button. Now remember, this is an option, so you do have to have that option on the machine to see this. Once you select program sync, now you're going to give it a name. So we're going to call this, we'll just call it part 1. Keep the same name as we have. So our job file can match the folder name. That's okay. We could have a couple different part series within that folder as well. And then I could use a different name. But what it'll do is it's going to now use that name when it goes to create by selecting OK, my 2 names of my channel program. So these are 2 individual files it's going to create for me. Like I showed you before, it can be G code, that can be shop turn. The second one, pick my choice. So in this case, since I'm creating brand new files, it's going to now allow me to build the programs on the fly. So I select OK. It's going to show me my job list. As I said before, I'm going to choose the work coordinate. I wanted to use G54. Now, you may see this describe option. Now, describe is important to understand because in this case, when describe is activated and I run this job, whatever number is in here, it's going to plug into the G54 work coordinate, and it's going to do it automatically for both my Z and my Z2 field. So I like using the describe. I can use the describe because I've done the front end work and figured out all of my nesting. So I don't have to put a part in, come over, touch off the part like I normally would. I know that I want the part to stick out. We changed the numbers here. I think the projection was 3. So I can now set it with a scale if I wanted to. And I'm going to let the program actually dump the value into the work coordinate field. So that's where this number comes in. I don't have to do this. I can do it as a second step, but then you must set this to no because it will overwrite it. And then set up your blank like you normally would. So what is my blank? What's my OD? How much material did I leave on for a facing cut? What's my overall length? And this one's important. So think about your final length dimension and how much material we're going to be leaving. So if I bring up the part print here, grab it real quick. This is a 4-inch overall finished part. I said I wanted to take 50 thou out aside. That's why I'm starting with an incremental. I decided to work everything from my 0, an incremental distance of 4.1. So you want to make sure these things stack, because when you simulate it, if you get any discrepancy there, it might not look like it's actually taking the right material off when you get to simulation. This doesn't have any bearing on the run. That absolutely has a bearing on the run. Okay, there's my projection, how much I'm sticking out from my jaw. You can, if you have this option turned on, write that chuck data like we saw in the settings screen. Since I've already set it up there under offsets, I can leave it at no. And then I'm going to do the same thing on my counter spindle. So we're telling it we're defining the counter spindle. I'm using G55. Now here, with this mirroring option, it's going to keep me from having to actually go into the G55 and set up the mirroring. This is going to do it automatically for me. So when I run this and I go to my offset table and I look at the actual work offset for G55, it's going to end up with checkboxes here automatically for me. But it doesn't happen during simulation. It's going to happen when you physically run the file. Okay, so we fill out the page, right? Finish up our projections. We say accept, and this is now what the editor is going to look like. So that multi-channel data, that first page that you saw, which is really the job file, that is this top bar at the very top. So if I want to get back to it and my highlight's down in either of the two channels, right? I'm writing code, just highlight the top bar. You can either click this little arrow, you can hit the blue arrow to the right, but this is always going to get back to that job file setup. Once you've done it, the system automatically builds the cycle 208 for you. And that's going to be basically linking this channel program to the job file. So that's where the part 1 name comes in. Remember, that's the job file name. The channel name is part 1_1 or part 1_2. So both have to have that cycle. You don't have to do anything with them. They happen automatically. So really all the fun stuff starts right here. So now we've got to start writing the program. We got to write safety lines, tool changes, all the stuff it's going to take to machine this part. So we're in the editor and we're going to start writing. So I'm going to start with a pretty traditional safety line, right? And I do want to think about where I'm at. I know that the job file said that my main spindle is using G54, but remember, we're in G code here. I'm driving a manual car, so I am going to have to tell it my work coordinate. Would want to tell it my unit of measure, right? So my G700 and my absolute, what's my plane. So this is all standard stuff that you guys are used to in traditional turning technology. Want to define whether diameter mode's on or off. This is going to throw back to when I was doing the layout, right? And I was thinking about the safe position that I want to send the turrets. Well, is this a diametric location or is this a radial location? So SUPA, the command that we've used many, many times over, suppressing our active work coordinate. Well, SUPA will change the X value based on the diameter mode on or off. Some people don't realize that. So you want to understand what's going on there when you go to establish it. Then I'm going to send her most likely to a safe retract location in both of my two channels. This is my opportunity, not knowing where the counter spindle is in space, to send the counter spindle to a safe location. At the exact same time, I'm going to load up G55 because I know that's the work coordinate I'm going to be using for the second channel when I go to machine on the counter spindle. Planes, well, this is very similar. I'm going to use the SUPA station or safe retract location that I set up before for now the lower turret. Once we've set that all up, then, then we're going to get in and start writing our part program or operations. So the safety line, I tend to start to plug that in at, one channel at a time. So we said we want to be in G18 because we're going to be turning. What's nice here is I'm working with the two channels. I can now copy and paste between them to kind of save me some time and then just change what I know I want to change. Oops, that's a fat finger. So here I'm going to use G55. There's going to be G54, right? Then we said we were going to put our diameter mode on. We're going to do our SUPA to go to our safe retract location. I was using X of 12. If I was to bring up the reference sheet, Z, I believe I was going to 20. Y, I might as well send to 0. If I needed to maybe clock my spindle, I could then address my C axis on that one. We did say that I was going to also pre-position. Now, on axes, when we look at the axis designation, right? Oops, not that one. I want to bring up this, and we'll look at page 2. When I look at an axis like my Z3, If I have to designate it Z3, then how would the system know after the 3 what's the numerical value associated with it, right? I want to move my counter spindle to 40 inches. So when you do have an axis designation that has like a letter and a number associated, you are going to have to add an equal sign to it, and then you tell it where it's going. On the other side, I don't need the last SUPA, but I do want to have, all right, my diameter mode on. I look at the safe retract position. Now in this case, maybe I have a little less travel. So here I was using a 10-inch retract at only 18. So I'll change that slightly. I'll make this 18. But this is really how it starts to work, and I can just bounce between the two channels. This is where it gets really nice seeing both channels at the same time, because there's a lot of commonality between them. This is also where I went to that mirroring option. If I do one operation here and it's the same steps over there, I can copy and paste them real quick, and I won't have to flip all my Z's and rearrange all that kind of stuff. Now, once I get through, I'm now going to start to think about my operations, right? So what I like to do, I'm a big proponent of using our groups function. So I'll use this group command to then kind of link and put a lot of my toolpath and functions within a group. What does the group allow me to do? Well, it really just lets me expand and compress large chunks of code so I can see kind of the overall program and potentially fit the whole thing on one screen when I have all of my groups suppressed. And then what I'll do is I'll build myself a group, an Op1 for that operation in channel 1, and I'll do the same thing in channel 2. So wherever I have, the same thing happening at the same time, I can kind of bounce between the two of them. Now, you can build groups, certainly from a CAD/CAM system. When you look at it in our editor, like we're showing back here, you're just going to see the result, which is the graphical feature of this group command. If you take the program out and look at it in a text editor, you'll see this command structure. So the group begin, group end. Within the groups, you are only really going to tell it what the naming you want, and then potentially the spindle. Now, the spindle command in shop turn, if you've seen the shop turn or done any shop turn programming with groups, this is real important when I'm taking and moving a turret from like a main to a counter spindle, because that's what drives it. Here in G code, it doesn't matter. Everything's going to be driven by the work coordinate you activate. So it'll be up to you. So if you want to designate the spindle here, that's you can. It's not really going to help us a whole lot. I like to, just so I know kind of intentionally what group is going to what. So when you see the graphic, you'll see there'll be a little spindle designation right here on the end. That would get triggered by this other variable in the group command. So what do we want to do? Well, in Op1, I want to come through and I want to load a tool. I want to set up some feeds and feeds, do some kind of an operation. And then at the same time, I'm going to allow, this would be the cycle that we're going to use for turning our part. I'm going to allow my channel 2 to do the same thing. So I like to call them both the same op, right? Because they're happening at the same time. So I have two different operations happening. They don't necessarily have to be both called turning, but I will try to align at least the op number between them. So visually I can kind of get an idea of what I'm intending to happen simultaneously and what I'm not. So we're going to do the exact same thing here. We're going to set up, load some tools. Here you're going to get to see your axis designation, setting our main spindle. I will just use cycle 951 to handle the turning path. Certainly if this was coming out of a CAM system, we'd see just a lot of rapids and lines. And then we'll get a chance to simulate it, and we'll start to see the simulation of the actual multi-channel program. So if I want to build a group, I want to be here in the editor, either area where I want to build a group, and I want to select the edit button, have that highlighted. You'll see your build group option. When I select it, I'm going to give it some name. So I'm going to say this is going to be Op1, and Op1 happens to be turning at least on the main spindle. And I do want this to be happening on my main spindle. I know S4 from my little cheat sheet, so I'm good there. And now we can expand or contract the group with this little plus symbol. I can hit the arrow over if I wanted to change the name, But keep in mind that S4, that's not going to have any bearing on the actual tool path. It is up to me to make sure I load the appropriate work coordinate on the operation that I'm doing. So, time for a tool. I'm going to select the select tool while in channel 1. And what will happen is, since the system knows, oh, well, he's in the program that's associated with channel 1, it's going to show me the turret from tool table for channel 1. It is not dependent on that channel button I showed you. So had I been over here in channel 2 and I hit select tool, you see how it says TOA 2 now? So now it's showing me the turret for channel 2. So I'm going to be back to channel 1. I'm going to grab a simple OD tool. Now in this case, the picture is very important. This would be how it's sitting in the physical machine, so that I could immediately know, okay, that tool is a left-hand tool. It is an OD turning tool, so I should be able to face and I should be able to OD turn with that tool. Now, depending on the machine and the configuration, it may require some form of an M6 style command or an additional cycle. DMG uses this TC command. I'm not going to go into the detail on that because that is OEM specific. Some machine builders won't have any type of TC or M6 command. It'll issue solely on the T code. So that would be a variance based on the machine, OEM. I do want to set my spindle, so I'm going to set my main spindle to number 4 because that's going to be my primary spindle for cutting at this stage with this channel. I want to use the S4, meaning the S code is mapped to spindle 4, so I'm going to be running this at 1000 RPM. And the same thing when I address M codes on multiple spindles. I'm going to tell it the M code for spindle number 4 equals a 3 for spindle clockwise. Maybe I want to tell it what my feed rate is going to be. Is it feed per rev, feed per minute? What do I want to run my feed? Whoops. So I'll go 10,000 per rev when I get to a cutting command. Here I'm just going to wrap it over to 4.1, knowing my stock, oops, if I put an X, is 4 inch. My Z, I'm going to send it right to 0. Once I come into position, I may want to give it my G1 at this point. Tell it to go, I don't know, X negative 30 thou, we'll say, get down off the part. I'm going to back off. Ooh, I am just jumping over commands right and left here. Back off to Z.1, jump up to an X 4 inch. In this case, because I know I'm going to come right back into a turning cycle. So almost everything I have here, I'm going to want to do on the other channel to face off the other one at the same time. So these groups, I am allowed, and it can be it can be open or closed, but I can copy, and I can copy the entire group. So if I want to get large chunks of code back and forth, this will all work. And again, since we have the mirroring, this is going to handle everything up until the tool change, because that could be a problem, right? I'm using a different tool. So now if I look at my lower turret, since the lower turret is on the bottom, now my left-hand tool, right? If I look at it, it's going to have the insert up and to the right. So it's, again, it should always match how it physically sits in the machine tool. So I'm going to highlight that, drop in that tool. Now I am working on a different spindle at this point. So I have a couple things I need to change. I want to tell it spindle 3 is my counter spindle, M3, but everything else should work. So I should now have 2 faced off parts. Now in channel 1, I am going to add a simple little turning cycle. And I used the basic stock removal. I wanted to use the corner breaks because if I look at the part print, it's got some chamfers, some radiuses. You guys, I'm sure, know how to use these cycles, safety distance, where do I start, where do I end, the basic geometry here. But this is going to handle now machining this segment. And when I jump over to the other channel and I go to the same cycles and stock removal, what's cool is, see how these are totally different numbers right now? So if you're familiar with the way our cycles retain the values, they'll retain the value in the specific channel. So it's not going to suck the numbers from channel 1 into channel 2 here. So in this case, I'm now using, because I have this back taper, slightly different modification of this cycle. From here, it's all the same, starting, ending. How do I want to calculate or describe the angle, and what are my corner breaks, depth of cut? So we drop in the 2 cycles. I'm just going to get rid of these spaces because they're not required. So if I went to simulate right now, I just go over to simulate, and we should see both channels pop up. So there's my main and my counter. Now what's new here is we're probably used to this. So I could just look at the one spindle. I'll actually see the second spindle here. If I run it again, you can do that. So you can zoom out and see both channels working at the same time. Or once it's all commissioned, I get this additional counter spindle button. So now I have 2 windows, so I can really look at either channel as I go. Now I see when I'm done. At the M30, it's just sitting here. I haven't told it to retract or any safe spot, but we can start to see the face-off part. We see that my Z negatives are all going into the part, and they flip-flop based on the mirror command. And we can start kind of building off there. Okay, so we have some turned scenario. Now we're going to jump back. We've simulated a little bit, and now we're going to talk about weight commands. So what I did do, which is kind of a no-no, I think, when you get to these types of machines, is I never told channel 1 or program 1 to wait for channel 2 or channel 2 to wait for channel 1. So the problem is with that scenario, had I been running this part in auto, and let's say I'm going to induce a very small cut per pass on this channel, so it's going to take longer for it to run, right? So now what happens is, if there's no way of having one channel wait for the other, as I run, it's going to be doing its thing, everything's happy, you see both channels are running. Well, when channel 1 finishes, it's going to reset the program. Now channel 2 will keep on cutting, but now I'm leaving this program number 1 or channel 1 in a non-active state, right? Could be plenty of reasons why that may not be an optimal situation. So what we want to do is we want to start adding what we call wait states to say, hey, before I move to the next operation, and it may be something as simple as moving to an M30, I want you to wait for the other channel, and vice versa, right? That is all done through these wait commands. So this wait code. Now, you will see there's a bunch of options when you get to the wait codes here. And I will tell you, on traditional multi-channel machining like we're doing now, you only ever really need this wait M. Some of these other ones, they were really designed for, you know, like 3, 4, 5 channel machines, like screw machine types of machines where I have 6 or 7 bar spindles running at the same time. You can get into all kinds of crazy optimization if I'm trying to tweak out, you know, tenths of a second here, because this is a 1,000,000 part production run. But when you're first starting and working with these wait commands, honestly, wait M is going to do everything you need. What's happening here is this is changing maybe the exact stop mode. It's trying to kind of refine or speed up the changeover process. So we're going to use wait M, and then also I'm going to have the ability of toggling which channel's waiting for which. To be honest, this type of technology, when you're first getting into it, you're always going to want both at a yes. There's really no reason to set one to yes and one to a no. That also comes in when you're getting into much more complex, I would say, you know, 3, 4, 5 channel style machines, where those channels are all cutting channels, right? Multiple slides and all that kind of crazy stuff. So wait M is what we're going to want to use. Now we will assign a number to our wait code, and then we'll set them both to yes. And then we're going to get into drilling in our next op. So how would I do that with a wait code? Well, I always like to put my wait codes outside of my groups. So this way, even compressed, I can see my wait codes and see kind of how they line up. So here, to get to the wait command, I don't have to type it out. If you go to various and you expand your vertical keys over, you get a wait marker. And that's our little conversational page that allows me to plug in a wait command. Now, this is the way I like to do it. certainly up to your own your own techniques as well. But I always end the bottom of my program with a weight 99. So the maximum number of weight codes you're allowed to do is a 99. However, if you need more than 99, that's okay, because you can redo the same numbers in a row, or you can redo the same numbers, just don't do 2 weights in a row of the same number. So I could have a weight 1, weight 2, back to weight 1, back to weight 2. But I'll generally always put this bottom weight 99s. This way I don't really have to think about my next weight code. But since I know there's another operation coming, what I'll do is I'll add an additional weight code here, and I'll start with weight 1. And I like to 1, 2, 3, 4. I like to count them up. So whatever weight number I have in channel 1, the timing between the two is having the same weight number in channel 2. So by doing this, and both say they'll wait for each other, now when I go to run and I hit cycle start, you'll notice once this comes and it's done with its operation, it's going to sit on the wait command, and it's now waiting for this other channel. So I'm still in an active state. So my main spindle's still live, it's still holding position, and it's going to just kind of sit here until I've completed. Once I got to that weight marker on channel 2, it released. In this case, the next command was an additional weight, but it blew right through them because there wasn't anything to wait for, and hit your M30. And then we'll just start adding our toolpath below these 2 weight commands. So the next toolpath, if we look at our part program, is adding in our drill. Now in this case, I was thinking to myself, well, what if I have an operation where I want to send one of the turrets to a safe location and just kind of have that one sit there, not multitasking, not physically cutting on the other spindle, and then I'm going to let the other turret go and do some kind of an operation. So that's what we're going to do here. So we're going to use channel 1. She's going to go up and go to a safe spot, our SUPA condition. I'm also going to stop my primary spindle because we're going to use a live tool that's sitting in the lower turret to come and drill our hole. And then all of our drilling is going to be done in channel 2. So channel 2, I'm going to retract to a safe location because I will be doing a tool change. I'm going to load my solid drill in. I'm going to now change my main spindle to that spindle, that number 2 spindle, right? That's my lower turret. Give it some speeds, feed rate, and we'll just use our simple cycle 82 to drill our hole. So I'm going to create 2 groups again. I'm going to create Op2, and we're going to call this drilling. And we're going to say the drilling is all happening on my S4, and we're going to have the same thing over here. So if I want to just copy a group by itself, I can do that as well. Then we're going to put some code in it here. So in my drilling on my main spindle, in this case, we were going to go to our retract state. I'm just flipping my little cheat sheet because I honestly don't remember all these numbers right off the top of my head. Okay, so as far as the safe retract, I'm going to use the safe retract I've already established. So I'm just going to copy that down and drop that into, oops. Did I not get it? Maybe I didn't get it. Copy. There we go. So I'm going to drop this down in. I did mention I want to stop my main spindle. So M4 is going to be a 5. And now at this point, my CNMG is still loaded. She's just up sitting at my safe retract, giving me maybe room to get the other turret down in to drill that hole. So if we jump over to our Op2, now this is the one that's going to do all of the heavy lifting, right? So I do want to send her to a safe retract point. So I'm going to copy, come down, paste it in. I want to do my tool change just like you saw before. And I'm going to grab, in this case, my solid drill. Once I've loaded my solid drill, I'm going to want to set my main spindle. I always like to set my main spindle prior to actually activating or starting that spindle. I'm now going to designate, and we'll just do some default speeds and feeds. So spindle number 2 and M code for spindle number 2 is going to be an M3. I'm going to want to certainly maybe sell it G94 for feet per minute, some kind of feed rate. So we'll just go 10 inches a minute. Let's come on down so you can see what I'm doing here. Now at this stage, I do need to tell it to switch, because remember, I'm on G55. So I can absolutely jump over to G54 now. And I'm going to want to change my plane type because I'm no longer turning. I'm not using a G18. We're going to drill. And we'll use a preposition to rapid to maybe X0, Z of 1 inch in front of the part. And we can use our drilling routines under drilling, all our standard cycles. I'm going to do a basic drill to now stipulate where do I go when I'm done, you know, all the normal stuff you would do. Now I'm going to use a single position because I've already pre-positioned my X to be at 0. My Z fields get handled right in the cycle. So as long as I'm at single position and I say accept, she now drills the hole. Now what I want to do before I finish up this op is I want to get in the habit of putting my wait commands in, right? So at this stage, I can go back to various, expand over, use my wait marker. I'm now going to tell it, and this is why I kind of like the numbers to match my operations. I think it stays a little clearer in my head. So I'm going to do a wait command for both of them as number 2. So that's saying, hey, you're going to hang out until the other one catches up. So now I have my 2 wait commands. If we go simulate, we should now have a part with a hole. Now, when you get in here, you can go into 3D views if you want, half cut, you want a sectional thing. So all the stuff that you're used to, it's nice that it'll do them simultaneously. So there you see she's turning. That one's waiting for it to catch up. I haven't changed the depth per pass yet. I can kick that back up. Now it comes over drills. So the other turret, the upper turret in channel 1, that's just sitting up in my safe retract. And then we can start to continue on in the program. So this is going to be how it starts to build. And then, you know, I can compress chunks of code with these little group commands. So you see what was now a multi-page program can be consolidated down. I see my different wait commands for me, and I start kind of working down the program. Okay, so what's next? What is next is we want to take a look at a function called Synchronize. And this really becomes handy once you start to have some data on the screen. It can be a little confusing. What is timed with what? So the Synchronize View function allows it to automatically sync the 2 channels from a visual perspective. They're always going to be synchronized when I run them by the wait codes. But if I want to see how they look side by side, I can use this function. So when we're in the editor, if I'm on edit and I expand my vertical keys over, there's a view button. And in a multi-channel machine, I get this synchronize view. So I can click synchronize view and it starts to move things around. So what it's doing is it's aligning my wait codes. Now it doesn't look like a big move right now, but what if all my blocks were open? Now I can see things line up for me. So I see up top, turning 1 is waiting, right? It's waiting for this one and that one to be done. Then it goes into drilling. Drilling's going to wait. So you see it adds a bunch more lines in here. So I see right off the bat how it's going to kind of all lay out. And you can turn this on or off just by hitting the sync view. If it gets out of sync, you can hit the synchronize and then it will automatically synchronize them. That's what this little button's for. The other thing that's cool within the this view option is the open and close blocks. So what that does is that actually takes your program blocks, right, that we've been building as we come through here, and I can say, hey, I want you to close all the blocks. I want you to open them all. It gives you like kind of one-shot deal. Now, the other thing you might see and start to notice is these little yellow and blue timestamp numbers. So when you start to build blocks and wait codes, it'll show you cycle time, because I've already simulated it, and I do have to simulate it for it to grab it, for the different operations. So if I'm trying to figure out my timing and how it all works, I can start to look at my different operations and see, like, I see Op1 only takes 1 minute and 37 seconds. Op2 is taking 6 minutes. Well, I know that's because I put some crazy small cut amount there, right? Depth per cut. So now if I re-simulate it, and you do typically need to re-simulate it for it to recalc. Starts cutting. Sorry, I inadvertently muted myself. So now we're cutting. You see how much faster they were synchronized. I jump back. Now, minute 37, minute 49. So you can really kind of get an idea with this whole structure where you're losing cycle time, what operations are taking longer than others. Okay, so we are just about there. So I come back in. Now we have one final operation. We're going to drill the other holes, and now I want to now use my upper turret, but I want my upper turret to come over and work on my counter spindle. So here I can then send the lower turret to a safe retract location, go do a tool change for my upper turret, jump over, change my not only my plane, but my work coordinate, because I want to send it over to the other turret. And then I'm going to do some simple C-axis drilling, right? So we're going to do 3 holes wrapped around the C. I'm just going to do a position with my C command. And I like to, especially if I'm intentionally using that turret on my main spindle, quite commonly, I'm probably going to want to flip my work coordinate back. Really depends on what's happening. Once we do this, then we'll do our final transfer, and you'll see the whole thing come to completion. All right, so I'm going to compress some of these up, and I'm going to, oops, didn't want to close the program. All right, so when I want to reopen, I come to the part program. I don't want to open the individual job file or the individual part program files. If I do that, I'm just going to see that channel program. What you want to open is the job file. So highlight your job file, open it like you'd open any program, say okay, and now you're in, and you're in this synchronized view, right? You're seeing both programs at the same time, and we can start to build. Now, if Synchronize View is still on, which it looks like I left it on, I did, it'll synchronize them even as I write them, which is kind of handy. So we'll build our next group. This will be Op3, and we're going to do drilling. Maybe I'm going to call this my 1/4 inch or whatever reference for you. All my drilling is going to be happening on my other spindle. Again, that S is merely just for my reference. It's not going to have any bearing. I have to do that all with my work coordinates. Oops, I want to open up my block. Why is my cursor gone? There we go. All right. So we send, so this turret's going to do our heavy lifting. Why don't we jump right in and get my lower turret out of the way? Remember, right now it's down kind of in the center. I just drilled that hole. I haven't moved it since, so I'm going to do a retract. And remember, SUPA is independent of the work coordinates, so I don't have to worry about what's going on there. So we're going to send her to that safe location. And then really, that's about all we need to do there. I could certainly maybe shut the spindle off if I wanted to shut off my M3 = 5. And then we're going to go into, it's going to go into an M70 or positioning mode. Here, I definitely want to make sure the turret is at my tool change location. Now, it happened to have been, I'm a big advocate for redundancy, so I'm just going to make sure it certainly is. We're going to grab our next appropriate tool. Obviously, I pre-built and staged the tools for us for time's sake. Now that I have it, I want to come down. Flip my page too quick. Okay, so we're in our SUPA, load it. I want to set my main spindle. We're going to set it to number 1 because that's going to be my live tool, my upper turret, right? I turn it on. Now, in this case, if I want to maybe program or position radially, I can certainly turn my diameter mode off. I would want to be in a G19 because we're peripheral drilling. I want to make sure that I'm on G55, making sure it's going to go over to my my counter spindle. We're going to fire up our spindle. So S1 equals some RPM, M1 equals, and we'll zoom clockwise. Going to rapid. Now on my part print, I gave us just a quick little reference. So I'm going to position this on an angle. So I'm going to come a little bit high where we're going to go out to 1 inch 150 radially. So that's where I'm going to position now, X of 1.150. I'm going to go to a Z of minus, center of it, I think was, what did I do, 3/4 back, so minus 0.750. I am going to want to make sure my Y is at 0. It hasn't really been positioned at all, so it should stay there anyway. Wouldn't hurt me to put it. But I do want to clock my spindle, my counter spindle, so C3, and I'm going to put it wherever I want to drill my first hole. But I'm going to do a modal command here now. So I want to jump into my modal drilling. So drilling, we'll just do a basic drill. I think last time I probably used my drill ream. Yep. So G19, a little redundant. You don't have to put it if you leave it blank. Same thing from a cam side, or you can certainly have it. But you do want to make sure if you're going to call out the plane that it matches one you've already set. So our retract position, so here I wanted 1.150, right? Safety distance off of it. My drilling, so we're going to come down to a 1 inch diameter, or I'm sorry, we're going to start from a little bit more than that, 1.150. Let's go a little bit more here, 1.2 and 1.250. Stay off of it. Close enough. All right. Give it my end position. Hit accept. Now my drilling's turned on modally. I do have to give it some locations. So even though I'm already sitting at my 0, I do need to kind of tell it right now that I want to drill a hole there. So I want to do a C3 equals 0. Then we'll do a C3 equals 60 degrees or 120 degrees. And a final C3 equals 240. That's going to get me all the way around. Once I'm done, I want to cancel my drilling. And we're in Op3 now, right? So just to keep everything the same, I want to jump to the bottom of my group, put in my weight code, and I'm going to now do a weight code 3. And I want to make sure, now in this case, it's yelling at me because I'm in Synchronize View and it's saying, hey, how do I synchronize with a 3? It doesn't exist. So that may be a scenario where I might not want to leave that view mode on when I'm just kind of roughing in my program. So I can just turn synchronizing off and then it won't yell at me. If I turn it on, then everything gets synchronized. Okay. So we've got some holes. So if I take a quick look at it, we're going to get around the perimeter. I know we're getting close to the end. I will certainly stay a little longer. I had a feeling this one would run a little long. There's a lot going on with this to go through any questions that you guys have, if you can hang out for a little bit. So we got one final operation. Our last operation is going to be our part transfer. So you are, and I can just show you real quick from a slide perspective, you're not limited to just viewing the 2 channels. Here we can actually open more programs. So obviously if I had more channels, I could have them all up on the screen. But if I want to grab content from maybe other programs, I can still do that. I can still open a further program. Now in this case, I've already pre-staged this one to support all the appropriate M codes for chuck open and chuck close for this specific machine OEM. I would need to make sure that those M codes match my machine. I'm going to do my primary transfer is going to be handled in my first channel because that's really the channel that my Z3 exists in. So in this case, channel 2 is just going to go to a safe spot, sit there while I handle the transfer. Now, I have no idea in this case what I have for an unloading command or function. So here we're just going to do a program stop, put up a message for the operator, hey, make sure you take out the finished part before I go grab the next one, because that could be problematic. Now we are going to open up the sub-spindle chuck before we come running over, so most likely it would just drop the part. But this is a quick down and dirty method if you don't have, maybe you have a bar feeder loading the machine, but you are relying on somebody unloading it. Just give yourself a nice little operator message to kind of plug into here. So to keep things simple, I'm going to get to my final group. And here I'm not going to write the full program for them. So things like transfers, that's a common function that you do a lot. So what you can do is under edit, you can just go open further program. And I specifically made some transfer files. So I made a transfer channel 1, transfer channel 2, and I can reuse these over and over again. Because if I'm just doing a simple pick and place, the only thing I would now have to massage once I come in for this transfer is really where am I positioning the machine as it comes down to do the pickoff. And why is that? It looks like I might have, yeah, those values aren't right. Let's close this one. Let me go. What do we got here? That one's okay. I've been jumping around doing a lot of stuff, so it looks like I had a non-edited operation there. So I'm going to actually grab it from a different part. That's funny. Let me just check that one last time. So when I look at this transfer, Z3, yeah, 425, these are metric values. That would not be the right transfer for this. So I'm just trying to save us a little bit of time. I do have this operation in workpiece demo. Yeah, this one should be right. We can go into that one. I do not want to be in my, oops. Hold on one second. This is the beauty of doing everything on the fly, right? All right, so, oh, I'm sorry, I was going into the wrong one. Demo inch. So this is the transfer file I want. So I'm just going to copy and paste. So you can copy and paste between programs, or I can bring it into the same, but this should have all the right numbers if I expand it. Yeah, 14 inches, 12.95. So those pick numbers, I got that off of that sheet again that I use, this Excel doc. This has allowed me to calculate some basic pick-off values. That's where I got those numbers from originally. So we're going to, a lot of times I like to compress when I copy the whole block. Now if we go into our program, I know I want this to be after that wait command. So we'll paste. There's my transfer. Like I said, I certainly could use the open further program, and we're doing that one. What am I keep going into the wrong program. I got too many programs in this machine. Open further program. Where'd you go? No, not that. Webinar. That's the one I want. The better you get at using, consistent terminology. You don't duplicate the same names like I did. That was horrible. Okay, so we have our transfers in. Now in this case, once the transfer is complete, I don't need to do another wait code because I know I'm done. So the wait 99 is sufficient for me to wait on the very end. This is a very basic pick and place type of scenario. So here we're going to see it cuts. Maybe I'll go to a side view. So I'm going to do all of my operations. And a lot of times when I look at the transfer, I like to actually go to this view because then I'll see the full transfer. So it's at my program stop. This would be where I would have removed my part, and then it does the transfer. Now what's cool here is once I've done the transfer, I now see the pre-machined part. So moving forward as I simulate, I'll actually see that pre-imaging part. So it's going to look a lot more like it legitimately will when I start running. So obviously, if you're going to do your first article, you're probably going to leave this turret blank, get through the other one, then do the transfer, and then it would look like this scenario. Now, if I want to see the message command, then if I was to go to real auto mode, this is kind of how it would look from an operator perspective, right? I'm running, I see both of my channels. Yes, I could bring up simultaneous record. When I get there, and I get to the end, it's going to come down and she's behaving funny. You would normally see the message command up. I hit cycle start and it continues on. Okay, we have covered a ton of stuff in probably what should have been a 2-hour webinar, but I do want to give it a chance to give you guys a chance to ask some questions. As far as open mode, auto mode, but the only thing I didn't show, but I showed it in MDI, you do have the ability of going into program control and suppressing different channels if you need to. You can hide channels like I was showing you in jog. But with that being said, let's get to some questions because I see there's a whole pile of questions. All right, so all right, right off the bat, I do see a nice super easy softball. Thank you for sending me this. Where can we find the old webinars? So go to the CNC4U website. So earlier I had, gonna zip on back, showed you, oh, not Mr. CNC. You can go to CNC4U, right? That's usa.siemens.com. And when you go there, oops, there is a link on the main page for webinars, or go to my Mr. CNC channel. All the webinars are there as well. And the past webinars, the easiest bet for all those past ones specific to this topic, when you're on the Mr. CNC channel, go to the, show it to you again. I showed it right here. Go to the playlist called Cinumeric Turning, and I have all of them there. So you're going to find my webinars sprinkled everywhere. Okay. The machine looks familiar. Yes, Brandon. Yes, it does. It does. You have certainly run a few of these before. What can you say? You might as well, you know, use the best to show the best, right? All right. Is SUPA similar to G53? So yes, SUPA is actually the latest command within this series. So G53 is a super old legacy command that we still do support. After G53, we came out with G153, and then we finally replaced it with SUPA. You can use 53 or 153, but if you look at what each of them do, each command actually suppresses a few more frames and functions in the system. And the reason why we've created a new command is because we created more functionality in the control. So what I would say is if you're using 53 now, start to get used to replacing it with SUPA. They can interchange, but SUPA actually is a little safer. It suppresses more on some of these advanced technology machines. Does shop turn support multi-channel programming? Absolutely. I did the series of webinars you see here in Program Guide leading up to this one. I did the same thing in shop turn. So there is a shop turn webinar under the playlists. I think if you go to the shop turn section, it's there, but if not, look in the main video section, you will absolutely find a webinar on shop turn multi-channel programming. And it works very similar. What are the two other parameters in the wait M command? So in wait M, all right, let's go back into it real fast and grab any one of my wait commands, all right? So we have the number, and then we have which is waiting for which channel. So it's really a rare case. Certainly, I have to have it wait for itself. If you tell it to not wait for itself, it's not happy, right? But of course, I'm going to want to wait for the other channel too. So on a standard twin turret style lathe, I can't tell you a use case when I would not want to set this to both yes, but it's really what's saying is, hey, am I waiting for channel 1 and am I waiting for channel 2? Yes, you are waiting for both channels at that point to be finished before you move on to the next. I've got a great response from one of our followers following Mr. CNC. He likes the channel. Thank you for the feedback. I appreciate that. Okay, let me jump over to the chat because I know we see a bunch of people put some stuff into the chat. All right, G700 is one, G710 is the other. Yes, for inch or metric. So inch mode would be G700, metric mode would be G710. Does using an RPM still allow you to use a constant cutting speed? So what I would do if I didn't want to be in straight RPM, I would then do my LIMS command, my limit max RPM, and then I would do a G96, right? G96 would be constant surface speed, and then I give it a surface footage like you traditionally would. So in my case, I was just running this simply in straight RPM, so that would be in a G97 mode, just to keep things easy. But if you go to those past webinars, I talk all about constant surface speed. I might have missed it. We mentioned before. I had to step away. Okay, I think we're good there. So what happens when the channels both work together on the same part holder or part? For example, upper and lower pinch turning. So when you get to pinch turning, there's extra timing commands. I don't think this machine was currently set up for, it might be set up for pinch turning. I will do a segment on pinch turning for you guys. But what you have to do is if you want both channels to work, you got to start timing them. So there's a whole host of extra commands that come into play to time them. If you're doing things like I'm drilling a hole on one side of the feature and the other, and there doesn't have to be a dependency between the both of them, then I can leave them untimed and just use the wait command. But the probability is you're probably going to have a scenario like in pinch turning where you need them to be synchronized. So there are some additional commands that come into play. So how would we would simultaneous push? I think this was just I realized out of the scope. I think that's really the same question as far as pinch turning. We do have full cycles to that. It seems like to be a little bit of interest on the pinch turning topic. Maybe we'll add in another webinar in this series to show you guys how pinch turning works. Or way to switch modes between the spindle. Changes from turning to milling mode. Will that make the other unhappy? I'm not sure if I'm totally following this question. Yeah, Jay asked the question as far as flipping the modes. I would say, Jay, reach out to me and we can talk about it a little bit more detailed. Can we have a copy of the Excel doc? Absolutely. You guys make sure you grab my email address. Oops, there it is. Chris Pollock at Siemens.com. Just shoot me an email. I'd be happy to send you over the Excel spreadsheet. We have a friend from Europe says it's getting late. He's got to go. I totally understand. When pinch turning with upper turret and lower turret simultaneously, who has the priority when calling CSS? Is there an M code to switch if the upper has or lower has priority? You know, that's a good question. I've never delved into the topic that deep. I would have to I'd have to look into it and get back to you. So again, that was Jay. We can talk offline. Is it possible to have channel 1 and channel 2 machines the same spindle at the same time? Yes, that's kind of what we're talking about with the pinch turning for sure. You just want to be careful if there's dependencies there. Oh, we got some more over here. I love all the questions. This is great. Mohammed from Bobcat. Hey, how we doing? Yes, we've worked together in the past. Thank you for watching. I appreciate that. I'm very interested in having hands-on experience with some of the Siemens centers. Any idea when you will resume in-person training? So we're hoping, depending on the whole COVID scenario, that we can start doing the in-person classes at our Elk Grove Village facility, which is just outside of Chicago, Illinois, sometime this summer. but you know, it's kind of out of our control. Hence why we've been supplementing a lot of this stuff with online classes. How can I run a metric shop turn mill program while the machine is in inch and do editing? So you want to be careful, Mike, and we can certainly talk about this a little bit offline. There's a machine parameter that will allow you to do that. You do have to set the parameter. The problem I ran into is the feed rates get interpreted in whatever unit of measure the control's sitting in. So basically, I know you're familiar with the difference between G70 and G700 and G71 and G710. So when you're doing that, when you're in conversational programming and you're running, the machine is in one unit of measure and the programs are in the other, it's going to run like it's in G70 or G71 mode. So with that, I don't feel that that's all that safe. So generally speaking, I don't show people how to do that. But if you'd like to know the MD, I can certainly dig it up for you. I actually just set that up recently. Okay, I think I got everybody. There were a ton of questions there. I appreciate everybody hanging out for me for sure. Hopefully you enjoyed this and we'll get a chance to talk again. If I missed anything, shoot me an email or give me a call. I'd be happy to talk about it. But with that being said, I'm going to wrap up. So let me stop the recording.